Gravity. We experience its effects every second of every day, and yet few of us really give much thought to this fundamental force of nature. When we walk, run, or jump, it's there, guiding our movements. When raindrops fall from the sky or leaves twirl to the ground in autumn, it's gravity at work. It even keeps our planet in its orbit around the sun. So what exactly is gravity, and why should we care about it? Well, in a nutshell, gravity is a force that attracts any two objects with mass towards one another. The strength of this force depends on the masses of the objects and the distance between them. The larger the masses, the stronger the pull. And the closer they are, the stronger the attraction. That's why when you stand next to a massive object like Earth, you feel a downward pull. You're being pulled towards the center of the planet. If you let go of something like a ball, it doesn't just vanish. It falls back to Earth because it's being pulled by our planet's gravity. Most of the time, we don't notice these effects because they're relatively weak and constant. But without gravity, our lives would be very different. We couldn't walk or jump. Water wouldn't flow downhill, and planets would drift aimlessly through space. Without gravity, life as we know it couldn't exist. But how does gravity affect us? Well, it's actually a very complicated question. Despite its importance, we still don't fully understand gravity. It's one of the four fundamental forces of nature alongside electromagnetism. The strong nuclear force and the weak nuclear force. But while we have a pretty good understanding of the other three, gravity remains a bit of an enigma. According to Einstein's theory of general relativity, gravity isn't really a force at all. Instead, it's a curvature in spacetime caused by the presence of mass. Objects move in response to this curvature, not because they're being pulled by any force. So in that sense, nothing is pulling us down to Earth's surface. We're simply following the curvature of spacetime, which has been warped by the mass of our planet. Despite the fact that we don't fully understand it, we do know a lot about gravity thanks to centuries of scientific study. We know that it's one of the most powerful forces in the universe, but it's also the weakest of the four fundamental forces. If you were to compare the strength of gravity to the other forces, it would be like comparing the gravitational force between two people to the electrostatic force between two protons. That's why we don't usually notice gravity in our everyday lives. It's drowned out by the other forces. We also know that gravity is always attractive and never repulsive, unlike electromagnetism, which can be both. That's why you can't use magnets to levitate a piece of iron. The magnetic force is strong enough to overcome gravity. So the iron simply falls to the ground. But you could never use gravity to levitate a piece of iron, because the only effect gravity has is to pull things together, never to push them apart. We know a lot about how gravity affects large objects like planets and stars. Thanks to Isaac Newton, we know that the force of gravity between two objects is proportional to the product of their masses and inversely, proportional to the square of the distance between them. This means that the further apart two objects are, the weaker the gravitational force between them. So the reason why you don't feel the gravitational pull of the moon is that it's simply too far away. But if it were closer, say orbiting just 100 kilometers above Earth's surface, you would definitely notice its gravitational pull. In fact, astronauts aboard the International Space Station, which orbits about 340 miles or 550 kilometers above Earth's surface, do feel the gravitational pull of the moon. As the moon and Earth's gravity combine, astronauts weigh slightly more on the station than they do on the ground. This is also why gravity gets weaker the further you go away from Earth's surface. As you move further away from Earth's core, the planet's mass seems to decrease, resulting in a weaker gravitational pull. But if you were to keep going up, eventually you would feel weightless. This is because you would be far enough away from Earth that its gravity is no longer strong enough to overcome the forward momentum you acquired when you left the planet's surface. At this point, you would essentially be in free fall, constantly falling around the planet, but never actually hitting the ground. This is what astronauts experience when they're in orbit around Earth. They're in a constant state of free fall, and they appear to be weightless. But it's important to note that they're not actually weightless. They're still experiencing the gravitational pull of Earth, but it's perfectly balanced by their forward momentum, so they don't feel any force. Gravity also has a major impact on our environment. It's responsible for many of the weather patterns we experience, such as wind and rain. When air rises rapidly, it expands and cools, which forms clouds and can cause rain. Gravity also causes water to flow downhill, which is why rivers flow downhill, and why dams can generate electricity by harnessing the power of flowing water. But perhaps the most important thing to remember about gravity is that it literally grounds us. It keeps us in touch with the Earth. It allows us to experience the physical world around us. Without gravity, we would literally be out in space. And while that might seem like a cool superpower, it's actually not. Our bodies evolved under the influence of Earth's gravity. And even small changes in gravity can have profound effects on our physiology. For example, when astronauts go to space, their bodies change shape because they're no longer being pulled down by Earth's gravity. Their spines curve, and their faces become puffy. After spending months in space, they often have trouble readjusting to Earth's gravity when they come home. That's because their bodies have gotten used to the microgravity environment of space. And when they return to Earth, they have to spend weeks or even months getting their bodies back into shape. Similarly, when astronauts train for long stays in space by spending time in bed or in specialized aircraft that simulate weightlessness, their bodies undergo changes in preparation for the microgravity environment. In fact, astronauts who train for long-duration space missions may spend up to 6 months in bed before their flight. This allows their bodies to adjust to the microgravity environment and reduces the risk of serious health problems. So you might think that it'd be great to be able to fly like Superman and soar through the skies with ease. But the truth is, we're just not built for that. Our bodies need gravity to stay healthy. More recently, scientists have discovered that gravity even affects how cells divide. In a study published in 2018, researchers found that cells grown in microgravity divided differently than those grown on Earth. Specifically, the orientation of cell division was affected by gravity. On Earth, cells tend to divide into 2 equal halves, but in microgravity, they often divide into 3 unequal pieces. This finding could have major implications for our understanding of cancer, since many cancers are caused by errors in cell division. Now, this might sound like a bit of a downer ending, but it's actually a pretty exciting discovery. Just think about it. Scientists are discovering new things about gravity all the time. And who knows what other secrets this mysterious force is hiding. Maybe one day we'll be able to harness the power of gravity to create new technologies or explore the universe in ways we never thought possible. But until then, we can marvel at the fact that gravity is one of the fundamental forces that makes life as we know it possible. I hope you enjoyed learning more about gravity. If you did, please subscribe to my channel for more science videos. Thanks for watching. See you next time.